Hello students, in the last session we have learned about the centroid of a triangle, and as you know very well, the centroid is the point of intersection of three medians of a triangle. So here you can have a quick look on the centroid of a triangle. If suppose this is the triangle ABC, and if we draw the three medians, and we have seen what is the median. Median is nothing but a line drawn from the opposite vertex to the opposite side, and this median will bisect the opposite side. So here also these are the three medians, median AD, BE and CF. So this point here, this is the point of intersection of these three medians, and it is denoted by capital G. So this is the centroid, the point of intersection of three medians of a triangle. Today we will discuss about the incenter. The next center of the triangle is incenter. So let's begin our journey for the incenter of a triangle. So incenter. So what is the incenter of a triangle? First we will see the definition. The point of intersection. The point of intersection of all the three angle bisectors of a triangle is called its incenter. The point of intersection of all the three angle bisectors of a triangle is called its incenter, and it is denoted by capital I. So here if we draw a triangle, suppose this is triangle ABC, and these are the three angles, angle A, angle B, angle C. So if we draw the angle bisector means if we divide each of these three angles into two equal parts, here this angle and this angle both are equal, or we can say angle BAD is equal to angle CAD. Similarly, the bisector for angle B is suppose BE. So here this angle is equal to this angle, means angle CBE is equal to angle ABE, and then the last and the third bisector is CF. So this angle is equal to this angle. So angle ACF is equal to angle BCF. So here in triangle ABC, AD, BE and CF are three angle bisectors. Three angle bisectors. Okay. So this point, this red point here inside this triangle is the point of intersection of all these three angle bisectors. So this is the incenter of this triangle ABC, and it is denoted by capital I. So first we will have to see, we will have to learn why it is called incenter. Why it is called incenter? Because if we draw a circle inside this triangle like this, and these are the three angle bisectors, then this is the point of intersection of all these three angle bisector, and it is denoted by capital I. So basically the distance this was AD, this was BE, and this was CF. Now if you see the distance from I to D and from I to E and from I to F, you can clearly see here that these are the radius of this circle. Suppose this is I, this is IE, this is IF, and this is ID, like this. So this is the radius, and this radius is known as in radius. This is in radius. So a circle was drawn inside this triangle. That's why the center of this triangle is called incenter. And the radius here, what we have drawn in this circle, we have taken this circle outside, and here it is very much clear that these three distances from center to the circumference of the circle are equal, and this distance is called radius, and in this case it is called in radius, because this is not just a circle, this circle was drawn inside this triangle, so that's why it is called in radius. So we can write the definition of in radius also. The distance between in center and its all three sides the distance between in center and its all three sides is always equal, and it is called in radius. So here in this case we can write ID is equal to IE is equal to IF, and it is equal to small r. So there are some interesting facts about this diagram, about this in center. So we can find the in radius using this formula. In radius is equal to area of this triangle, area of triangle upon semi perimeter, that is A upon S, and it is equal to small r, or you can further write it as, if the measurement of the sides are this is suppose small c, this is small a, this is small b. So the semi perimeter is a plus b plus c upon 2. So area upon semi perimeter. This is how we will find the in radius. Now one more point is here about the angle. So if we want to get the measurement of angle BIC, angle CIA or angle AIB, what will be the measurement? Angle BIC is equal to 90 degree plus half of the measurement of angle A. Angle AIC is equal to 90 degree plus half of the measurement of angle B. Angle AIB will be equal to 90 degree plus half of the measurement of angle C. Okay, now the last important point about the in center is in terms of coordinate geometry. Suppose this is triangle ABC and the coordinates are x1 comma y1 for vertex A. For B, vertex B, it is x2 comma y2, and for vertex C it is x3 comma y3. And these are the three angle bisectors. This is in center, this is AD, BE and CF, and you know the measurement of these sides. This is BC is equal to A, AC is equal to, the measurement is B, and for AB it is C. We have already seen this. Now the coordinates of in center I are coordinates in center I. The abscissa is AX1 plus BX2 plus CX3 upon A plus B plus C, comma, the ordinate are A y1 plus B y2 plus C y3 upon A plus B plus C. So these are the coordinates of in center, and as we have seen the centroid and in center, the two more important centers are still left there, which are circumcenter and orthocenter. So in the next session we will take circumcenter, and after that we will take the orthocenter. Hopefully you have understood everything about the incenter also. We will take the questions after completing all the four types of centers in the triangle. We will take some problems also, so that the conceptual clarity will be very much precisely done. Thank you so much for listening carefully. Thank you.